Hello class and welcome to lesson 7.2. Today we're taking a look at surface area of three-dimensional objects. Last class we just dealt with 2 dimensions, so now we're going to get into 3 dimensions. Just remember, ladies and gentlemen, that the surface area of a three-dimensional object is the sum of the areas on all of the outer surfaces of the object. Okay, and we use something that are called nets. So nets can be used to show the faces of an object. So if you take a look at, for example, at this square-based pyramid, okay, notice you can only visually see from this side 3 triangles, but notice there's one in the back, and what's making the base? It's actually a square. So that's why we call it a square based pyramid. Okay, and notice that those dimensions are the same. So when you've got a square-based pyramid, ladies and gentlemen, all 4 triangles are going to be the same when you're taking a look at doing that. So if I asked you to calculate the area of that, you would say area total equals the area of the base plus 4 times the area of the triangles. Okay, everybody good with that? All right. The next one, ladies and gentlemen, is surface area. Oh, sorry, draw a net for this shape. Now, this shape's called a cone, ladies and gentlemen. All right. So a cone, it depends on if the base is included. In this case, I want you to include the base. All right. Okay. So what we want to do is take a look at what would the net look like for that, ladies and gentlemen. Okay, so I'm going to extend my page. Sorry, let me erase that. I wanted to just drag that off. Okay, so taking a look at your net, you're going to have a circular bottom, and think about if you ever have an ice cream cone wrapped up like this, or a paper, one of those paper cups. If you unwrap it, or a birthday hat, you're going to see what that looks like. Okay, now if we wanted to do the surface area here, area total would be area of the circular base plus area of the, what do we call that, the side area, okay, or the cone if you want to call it. Okay, and you just look on your formula sheet, guys, that I gave you, and the area of the base is 2 pi r, or sorry, my fault, pi r squared, plus the area of a cone, which would be, if you look on your formula sheet, which is pi rs. Just want to double check that you guys know what S means, okay? So S is the slant height. So if I draw, that's my slant height. How do we get the slant height? Sometimes we've got to go from our height, which is h, and height is used for volume. And then sometimes you draw a 90-degree triangle and use Pythagorean theorem to get from one to the other. Just remember, slant height is the diagonal height or diagonal dimension, whereas height goes right from the top to the center of the base. Okay? All right, moving on here. Let's take a look at the next page. All right, so example 1, calculate the surface area of the square-based pyramid, and we gave you the formula, or you could just check on the formula sheet. Notice here we've got B, which means base, and S, which means your slant height. Notice your slant height here is the red one, so S equals 10 centimeters, and my base for the square equals 8 centimeters. Okay, so to calculate that, we're going to say surface area, okay, total equals the area of the base plus 4 times the area of the triangles. My fault, lost my train of thought there. Okay, so my base is length times width, but guess what? Base is base times base, so it's going to be base squared, plus 4 times the area of a triangle, which is going to be the slant height, which is S, so S times B divided by 2. Notice the cancellation here, ladies and gentlemen. I'm just showing you where that formula came from. So 2 goes into 2 once, it goes into 4 twice. So that's where I get B squared plus 2 BS. No BSing about it. That's how you get that, okay? So there's where we are. Let's sub in our information. So we know that's going to be 8 squared plus 2 times the base is 8, the slant height is 10. Plug it in your calculator, ladies and gentlemen, and you should get 224 centimeters squared. Okay? You could either put your units there, or you could save it and put it in a therefore statement. I would like therefore statements here, guys, for proper communication. So therefore, the surface area is 224 centimeters squared. All right, let's take a look at our next example. Haha, I love this one. A Toblerone bar has the following dimensions as shown in the diagram. Just so you know, the Toblerone bar, guys, when you look at that triangle, folks, it's an equilateral triangle, so they're all the same. So it's all 3 centimeters. So first of all, it says calculate the amount of wrapping required, and we're gonna exclude all the little folds that need to have the glue attached to them. All right. So how are we going to do this? First of all, we have to realize what do we have for surfaces. So area total, or you could say area of the Toblerone. Okay. Area total equals, well, how many of these long rectangular faces do I have here? Hopefully you realize that you've got one on this side, one on the bottom, and one on the far side. So you need 3 times the area of the rectangle. So you can just draw a little rectangle. Plus, hopefully you realize also we have one triangle at this end and one that makes the other triangle at the other end. So that's going to be 2. So plus 2 areas of the triangles. Let's do some work here, folks. So it's going to be 3 times, what's my length times width, plus 2 times the area, which is going to be base times height, divided by 2. Okay? Here's where we run into a little problem. First of all, before we get to the problem, notice there's a little cancellation out here, so that's pretty good. So we're left with, what can I sub in? 3 times 10 times 3. I got that. But here's where we got to find out what's the height. Okay? So we don't know the height yet, which is right there. So we have to use, it's supposed to be straight. My board has a little error in it. Okay, we're going to use Pythagorean theorem because we need to find, we know that the side is 3 centimeters, but the height we don't know. This base, folks, is half of 3, so it's 1.5. So remember to use Pythagorean theorem. So you're going to go h squared equals the hypotenuse, which is 3 squared, subtract 1.5 squared. Plug it in your calculator, ladies and gentlemen. You get h squared equals 6.75. And when you take the square root of both sides, you're going to get 2.598. I keep lots of decimals here, folks, because if you were to round that, you would round it to 3, and that would be inaccurate. Or 2.6 would be okay, I guess. All right, so sub that in here. So it's going to be plus the base, which we said is 3. And the height, ladies and gentlemen, we just calculated, is 2.598. Plug that all in your calculator, ladies and gentlemen, and you will get the answer of 97.79 centimeters squared. Okay? Now, it says for part B, convert the wrapping into square inches, because maybe that's where the factory orders it from. Okay? So what you need to do is use a website to find a conversion, or the sheet that I gave you. And the conversion that I will find on one of mine is that 1 centimeter squared equals 0.155 inches squared. Remember, folks, it's very important you understand squared units to squared units. You cannot use the centimeters to inches conversion. No way, because those are singular. Okay, so you cannot use them. All right, so what we need to do is say, hey, what do we have? We have 97.79, that's centimeters cubed. What centimeter unit do we have here? 1. What we want to find is the conversion, which is 0.155. To cross multiply, x is going to equal 97.79 times 0.155. Plug it in your calculator, and you should get 15.157 inches squared. Be careful here, guys. What's my units here? They are inches squared. So my unit of measurement, I should say, is imperial. So you can't leave it as a decimal. So you got to change it to a fraction. So it's going to be 15, and do some little fraction work here. And I have 5/32. It's pretty close. Okay, and that is going to be inches squared. All right. Have a great day, class. Here is our homework, page 136 to 137, number 2, 4, 7, 9, and 12. Have a fabulous day.